The term hearing describes the process or function of perceiving sound. Hearing is second only to vision as a physiological sensory mechanism used to obtain critical information in aviation operations. The sense of hearing makes it possible to perceive, process, and identify a myriad of sounds from the surrounding environment. Sounds in an aircraft are caused by the aerodynamic interaction between the boundary layers of the air around an aircraft, the surface of the aircraft fuselage, wings, control surfaces, and landing gear. These auditory inputs allow pilots to assess and monitor the operational status of their aircraft. You may also be exposed to a wide variety of sounds in the flying environment that can disrupt communication and, over a period of time, can cause hearing loss. The aviation environment is characterized by multiple sources of noise both on the ground and in the air. Noise in the aviation environment is produced by ground equipment and aircraft, including power plants, transmission systems, propellers, rotors, hydraulic and electrical actuators, as well as communication equipment. Most pilots have experienced a cockpit or cabin environment where levels of noise made it difficult to communicate and to concentrate on flying the aircraft. Over time, this environment can cause permanent hearing impairment. The auditory system consists of several components: the external ear, the ear canal, the eardrum, auditory ossicles, cochlea, and the auditory nerve. Ambient sound waves are collected by the external ear, conducted through the ear canal, and cause the eardrum to vibrate. Eardrum vibration is mechanically transmitted to the ossicles, which, in turn, produce vibrations to the flexible window area in the cochlea. This process causes the movement of thousands of hair-like sensory receptors that line the inner walls of the cochlea. This movement resembles the gentle movement of a crop field caused by the wind. The stimulation of these sensors produces an electrical signal that is transmitted to the brain by the auditory nerve. This signal is then processed by the brain and identified as a particular type of sound. The term sound is defined as energy that is heard resulting from stimulation of the auditory nerve by vibration of the organs comprising the ear. Sound travels in waves through a particular medium. The medium can be in the form of a solid, liquid, or gas. For our purposes, we are concerned with sounds that travel through the atmosphere, a gas medium. Sound has three distinct variables: frequency, intensity, and duration. Frequency is the physical property of a sound that gives it a pitch. Since sound energy propagates in a waveform, it can be measured in terms of wave oscillations or wave cycles. These cycles occur every second and are known as hertz. As an example, normal conversation takes place in a frequency range of 500 to 3000 hertz. The unit used to measure sound intensity is the decibel. The decibel is a measurement of sound pressure or loudness. To give you a better idea, the range of normal hearing sensitivity of the human ear is somewhere between -10 and +25 decibels. Any sound below this range cannot be heard. Duration represents how long the ear is exposed to a particular sound. Prolonged exposure to low-intensity sounds can be as damaging as short durations of high-intensity sound. The term noise refers to any sound that is unwanted or annoying. Characterizing a sound as noise is very subjective and varies from person to person. It's also important to remember that individual exposure to noise is a common occurrence away from the aviation working environment. Noise occurs everywhere, at home or at work, on the road, and in public areas. The effects of pre-flight exposure to noise can adversely affect a pilot's in-flight performance. Here are some sources of noise and their associated decibel levels. In a typical jet transport cabin, the noise can range from 60 to 88 decibels. A small plane cockpit can have noise levels up to 90 decibels. In helicopter operation, cockpit noise level can reach above 100 decibels. Around the house, a chainsaw or even a typical lawnmower can have decibel levels as high as 100 to 110 decibels. Prolonged exposure to higher decibel levels, such as a rock concert, which can get as high as 120 decibels, can cause major ear discomfort. Being close to a jet engine during pre-flight run-up, where decibel levels can reach as high as 160, can lead to eardrum rupture. A temporary hearing impairment can occur if your ears are unprotected and are exposed to a loud, steady noise over 90 decibels for several hours. Under such conditions, hearing will typically return to normal within several hours following cessation of the noise exposure. Permanent hearing impairment can occur if your eardrums are unprotected and exposed to loud noises higher than 90 decibels for 8 or more hours per day for several years. Now let's examine some of the insidious and subjective effects of noise in the cockpit. Performance. Noise is a distraction. It can increase the number of errors in tasks that require vigilance, concentration, calculation, and making judgments. Speech interference. Loud noises can interfere with or can mask normal speech, making it difficult to be understood. Exposure to loud noise can cause distraction, fatigue, irritability, poor sleep quality, loss of appetite, headache, vertigo, nausea, impaired concentration, and memory loss. The Occupational Safety and Health Administration, known as OSHA, has established some maximum permissible continuous exposure levels in a work environment. At 90 decibels, 8 hours per day. 100 decibels, 2 hours per day. 105 decibels, 1 hour per day. 115 decibels, 15 minutes per day. If ambient noise levels exceed OSHA's permissible noise exposure limit, you should use hearing protection devices such as earplugs, earmuffs, communication headsets, or active noise reduction headsets. The use of cotton or tissue in the ears is useless, as it does not block noise in the sensitive frequencies. It is important to emphasize the use of protective hearing devices does not interfere with speech communication during flight. These devices reduce high-frequency background noise, actually making speech signals clearer and more comprehensible. While there are many types of earplugs available, we'll review two major types, molded plastic and moldable. Both types of earplugs are inexpensive, effective, and comfortable. Molded plastic earplugs, also known as insert type, are effective if they are fitted properly. They create an airtight seal in the ear canal. Moldable earplugs, like this one, are made of wax-impregnated polyurethane. These provide a universal fit for any user. This earplug type provides protection of 30 to 35 decibels of noise across all frequency bands. The earplug is rolled between the forefinger and thumb and inserted into the ear. It should be held in place for approximately 20 seconds or until it has fully expanded. Earmuffs and communication headsets are other hearing protection devices that are readily available and in some circumstances more convenient than earplugs. It is important to realize, however, that these devices can interfere with the use of oxygen equipment. Active noise reduction headsets use specialized technology allowing sound and signal waves to be manipulated. This reduces noise, improves signal-to-noise ratios, and enhances sound quality. Active noise reduction provides effective protection against low-frequency noise. The electronic coupling of a low-frequency noise wave with its exact mirror image cancels out the noise. The best and most practical type of hearing protection is a combination of protection devices. Using earplugs with any of the following are recommended: earmuffs, communication headsets, or active noise reduction headsets. Protection for up to 60 decibels is possible with any of these combinations. Vibration is measured the same as noise, through frequency, intensity, and duration. Unlike noise, where the stimulus enters the body through the ear, vibration is transmitted throughout the entire body. Fortunately, most aircraft vibrations do not cause problems with body functions, nor do they cause injuries. Aircraft design is a major contributor to the amount of vibration that's transmitted to the pilot. Usually, the most noticed vibration is in a helicopter, followed by a fixed-wing aircraft with reciprocating engine, turboprops, and jets. Additional sources of vibrations include flying at low levels, near thunderstorms, in mountainous areas, and in winds. Another source could be uncoordinated flight control inputs by the pilot. Effects of exposure to vibration include difficulties in reading instruments and performing visual search, impaired speech, pilot-induced aircraft oscillations, fatigue, and back pain. As mentioned before, vibration is not a significant problem in aviation, but is one that a pilot must be aware of. In review, hearing is second only to vision as a sensory mechanism to obtain critical information in aircraft operations. The term sound is defined as energy that is heard resulting from stimulation of the auditory nerve. All sounds have three distinct variables: frequency, intensity, and duration. The term noise refers to any sound that is unwanted or annoying. Daily exposure to noise levels higher than 90 decibels can cause a hearing impairment. If ambient noise levels reach 90 decibels, it is necessary to use hearing protection equipment to prevent hearing loss. The best type of hearing protection is a combination of protection devices. It is important to emphasize the use of protective hearing devices does not interfere with speech communication during flight. Vibration is measured the same as sound through frequency, intensity, and duration. Vibration of an aircraft is transmitted throughout the entire body. Effects of exposure to vibration include difficulties in reading instruments and performing visual search, impaired speech, pilot-induced aircraft oscillations, fatigue, and back pain. And finally, exposure to any loud noises before flying, whether the noise occurs at home, while driving, at a party, etc., can be as harmful to you as is exposure to aircraft noise.